Hello and welcome to TidyX episode 52. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes, and you can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward, and you can find me on Twitter at OSPPatrick. And you can find TidyX on Twitter at tidy_explain. Or you can email us, tidy.explain@gmail.com. Or if you like a video, you can comment on YouTube.
Subscribe
We just
on
YouTube.
We hit 900 subscribers this week.
That's amazing.
Thank you for
Thank
subscribing.
you so much.
Continue to
900
subscribe.
is a lot.
Yeah.
You can open up a issue on the GitHub page if you have questions. And I think that's all the ways you can get in touch with us. Happy Pi Day.
Happy Pi Day.
Yeah.
3.14.
Yeah. Maybe we should start our script today with just a little pie.
Could do that. But yeah, so this week what we thought we'd do is we'd take you through how to do Xaringan presentations and the value of reproducibility in the work you're doing. Because we were talking, this week about how we'll get put on projects and working with people, and they're manually copying and pasting things in. They're just working really hard, and we're like, oh, R can do that. R can do it fast, and you don't have to redo it every single time there's an update.
Yeah.
So I wanted to go through a situation where this would work. So let me share my screen first for Patrick so he can see what we're talking about here. All right.
This is a fake situation. You weren't really collecting penguin data, right?
No, I'm not a penguinologist.
Yeah. Okay.
Or a zoologist. But yeah, so episode 52, presenting penguins, TidyX screencast. But so some context here. So say we're penguinologists, Pat, you and I, we decided to quit our jobs and go down to Antarctica to start collecting information on penguins, because that is our passion now. And we're stationed at Palmer Station number 2, which is a fake, not real. And if it is real, I'm apologizing to the folks that do work there. But Palmer Station number 2, and we're collecting data on penguins from the Palmer archipelago. And we're sitting there, we're collecting data, we're happy, working along, and our boss, PI, kicks down our door, masked up, of course, because we're still in the times of COVID, and proclaims the number of Gentoo penguins is too damn high. He's concerned that the techs are doing something wrong, that there's something wrong with the database, but he's looking at the numbers and he's concerned. Thinks that there's too many records being marked as Gentoo penguins, right? And he's just like, can you look into this, please? I'm concerned about this. So you're like, no problem, boss. I got you. So we do know that there is a good reference data set that is very highly curated and done very well in the Palmer Penguins R package that was maintained by Allison Horst and Alison Hill, and the data comes from Dr. Kristen Gorman. So I load in Palmer Penguins, I bring in the penguins data set, and I do a quick count and generate a GT to look at, okay, what is roughly their distribution of Adelie to chinstrap to Gentoo in their data set. And so we're seeing, they had, roughly 44% Adelie, and roughly 20% chinstrap, and roughly 36% Gentoo. So I'm like, okay, we're not in a very different spot. We're collecting data randomly like they were, so we should probably have a similar distribution, right, that they do.
This would be like in some of the previous episodes, the volleyball episode, for example. This would be like our base prior, right? Mm-hmm. We have a prior of what we, going in. And actually, this is the PI's prior, right? He's going in as the domain expert and saying something is wrong here, unless the Gentoos have somehow overtaken all of the other species, or the other species are going extinct. My prior belief is that we should see a distribution more similar to this, versus what we have collected.
Mm-hmm. Right? So we've got this reference data set. I'm going to load in my own data set. So I asked our text, hey, I pull in and export into a CSV our data. And so it lives currently in our Tidy Tuesday, or TidyX, as Palmer Penguins 2 100 CSV. Mm-hmm. So I load that in using read R. and I call it penguins too because I don't want to override penguins because that is from Palmer penguins. And I do the same thing. I take penguins, take the count of the species, calculate the percent, and I generate a GT table, and that shows up down here. And wow, yeah, we're having roughly 21% Adelie as opposed to the 40-ish before. There's only 6% chin strap, so unless the chin strap are gone, that's unlikely. And 73% Gentoo, and that's double, right? That's double what they were getting before. So yeah, I think there's something up with our data. Maybe our texts are screwing up. Maybe, I mean, not to put blame on it. It could be a database error. It could be an entry error in the thing. Like, it's totally, don't want to put the blame on anybody, but our PI's intuition was correct. Something's getting messed up here. And so let's do a quick comparison. So let's just make a quick GT table to like actually put this up here. And yeah, you can totally see the numbers are very skewed towards Gentoo with this nice little table here. So, all right. So, looks like the big boss is correct. But we know that there's a group of folks that put together a really nice random forest model that had a high accuracy in prediction. That might have been us last week. And we did not follow a bunch of modeling techniques, so don't take that at all with a grain of salt. So what I'm going to do is I'm going to read in that trained model because they saved it as an RDS for me very, very nicely. And I'm going to read that in, and I'm going to use the predict function on it, passing in the data that my team collected, because we collected the same information. We collected flipper length, weight, all those things, and I know that that's really accurate. So I'm going to throw that into my output there, and I'm going to assume that's truth because we know that this machine learning algorithm is very accurate. So this is, I mean, don't necessarily suggest using ML to double check your data, but this is what I'm going to do in this case because I don't know any better. And so what I end up with is this final table here, which is comparing the predictions from my assumed very accurate ML model against what was in my database. And yeah, it looks totally messed up. We're calling a bunch of Adelie, 29 Adelie we call Gentoo in our data set, 20 chin strap, 20 Gentoos were actually chin straps, potentially. And we only accurately called 24 of them as Gentoo, that were truly Gentoo. We didn't call accurately any chin straps.
Zero, right?
Zero for zero, NA.
Zero for zero.
NA, so like, clearly there's something messed up. So what you going to do about it? So we came up with this presentation. We go to our big boss. We show him all of these results. And he's like, great, go talk to the techs. Let's figure out something. Let's try to tighten it up. So we're going to go through the code here on how you do this. But he asked that at the end of the meeting, your boss asked, I really like this presentation. Could you please give another one in about a month? I want to see the same stuff here that you have in this presentation. I just want to know, like, after we've talked to our techs and our IT team, like, really look into this. Can you tell me, like, what's going on here? So you're like, no problem, big boss. I'll do that. Internally going, I built this with Xaringan, which is the method we're going to go through now.
Yeah.
So Xaringan is in our package from UA, with the same guy that made Rmarkdown and Knitter, our beloved reproducibility documents. And this is a way to create reproducible presentations. So wholly using Rmarkdown and R, so it's very familiar to most users. And you can just update what you need to update in your presentation, and it's going to be able to reproduce your same report. Very little effort.
Yep.
So I wanted to take a moment to walk through this and then say what would happen now that it's been a month later. So you start off your Xaringan Rmarkdown, the same sort of YAML that you always see at the header of any Rmarkdown. So we have our title, the authors, the date, and the output. And the output here, this is what defines it as a Xaringan presentation output. And so you use Xaringan, so Xaringan, : moon reader. And so this is the function that tells our Markdown renderer, render this as a Xaringan presentation. So you've used this. If this is like replacing your Rmarkdown : HTML document output. You just drop this in here. But it does mean that there's some special cues that you can drop into this presentation here that Moonreader understands and then will convert in your actual presentation. One of these is actually this first slide here that we saw, the background image. And so this is, you're able to put a background image for a slide. Here I put the TidyX profile JPEG. And then we open up with a R chunk, very similarly to any other Rmarkdown document. It's a setup, and we're going to say include equals false. And this means it'll execute it, but it won't show any results. It won't echo the code, anything like that. And so
it's interesting, the background image you put in directly into the body of the Markdown file.
Yep.
If you were doing this in a normal Markdown file, you'd have to put that in its own chunk. You'd have to put it in a chunk, and then you'd have to use the little at the top of the chunk. You'd have to include it in some way to make sure that it comes up in the Markdown file. That is that is a bit different.
Yes. So this is a special argument in Moonreader that you can pass to say, hey, I want the background image for this slide to be this.
Yes.
And so it's pretty nice here. So so we're going to load in, this is a standard R chunk, load in library tidyverse, library here, library GT, library Palmer Penguins, and library random forest, which are all the libraries we end up using throughout this entire presentation. But then you see more of these triple dashes. And what this does in Xaringan is indicate to the renderer that this is now a new slide. So anytime you see the triple dash, the content between them, that is the content of a slide.
Yep.
And then the format, exactly like any Markdown that you see. So the pound sign here indicates a header, and you can put multiple headers here for the level of header 1 through 4. So here it's top level header, so it's just number 1. You can put in a list here with the dashes here, once again, like our Markdown. So here's where we put in that context where we said we're a penguinologist at Palmer Station number 2. Right, so then we do triple dashes, indicate a new slide here, our hypothesis, and the way you drop in JPEGs, exactly the same way you drop in images with our Markdown, the exclamation point square brace, too many Gentoo.jpg, which is that meme that we showed there. Next, so then that's one slide. Then we have another slide where we're like, the reference data. And here is where we have once again our header, our standard a bullet here. This is how you link to things in Markdown using the square braces, and we're linking to the Palmer Penguins GitHub page, which is maintained by Allison Horst and Dr. Allison Horst and Dr. Alison Hill. Data is from Dr. Kristen Gorman. But we've loaded in Palmer Penguins earlier, so we now, through the lazy loading abilities of R, have access to penguins. We throw this into our count by species, and then that generates a data frame, which is species and n, number of records. We're going to do a mutate to calculate percent, divide n, so then the value of that row divided by the sum of that there, and then we're going to throw it into a super basic GT. No special styling being done to this GT this time.
Yeah.
Same sort of concept with our data, but this time we're going to be loading in the data. I'm using here to make sure that it's referencing the correct full path, because this lives inside of subdirectories in my R project. So then we're going to load this in, assign it to penguins 2. I didn't want a bunch of messages being printed out, so we're going to use the suppress messages argument here. So suppress messages, penguins 2, read R, read CSV, path. Assigning out to penguins 2. Same thing that we just did with the reference data here. Generate a similar count data GT. Next, just new slide, comparison. Now we're going to do our chunk of code, but we don't actually want to echo out the code itself. We want to just have the output. In this, once again, like our Markdown, we use echo equals false. And what this will do is it'll allow us to run the code, but it won't actually show the code in that slide.
Yeah.
So Patrick, do you want to kind of take us through some of the logic here?
Yeah, this is pretty much stuff that we've done a billion times. We take our data set, we run it through a count, which again will produce a count of the species, so it's literally just a value count. And then mutate, we're going to add a new column called %, which is the count of the species divided by the total count of the sample. So the percentage representative of each species within our sample. Then we're left joining that. So that's all done on the original Penguins data set, the full data set. We're left joining that to our sort of our fake tech collected data, which was simulated and built, called Penguins 2. We are going to left join that in. It's the exact same, do the count, mutate, %, blah, blah, blah. We're going to join these on species. You have to specify species here because we have the same column name. So both data sets, Penguins and Penguins 2, will have three columns. They'll have species, they'll have N, and they'll have PCT. And if you were to simply left join, R is going to say, okay, you want to left join everything. These are all the same columns, so we'll join on those. And you're going to end up overriding things. So by specifying species here, we're telling it only join on the species. So wherever you see Adelie, join Adelie. Wherever you see Chinstrap, join Chinstrap. And that's what gives us this those join data sets. And the suffix there is specified. If you didn't specify the suffix, it's just going to tell you .x and .y. Basically what that means is the X data frame and the Y data frame. So in this case, the Penguins data frame and then the Y data frame would be Penguins 2. That obviously isn't very descriptive. It's not very helpful to someone reading it. So supplying that suffix, I think you have a hashtag.
There we go.
Supplying that suffix allows us to have a bit of a nicer read of the data data frame. And then we're going to pipe that into select. So we're going to select species. Starts with N and starts with PCT. So basically, we're selecting those columns. And in this case, the starts with is saying select all columns that start with N, which is the count columns and N, and then select all columns that start with PCT. So this is how Ellis got in that presentation. He got that table that had a spanner over the top that basically was like a value count and then a percentage count. And that's what he's going to pipe into the GT table. So GT table, he's going to set the row names to be species because we don't want those to be an explicit column. The tab spanner is going to be the piece over the top of the table. And then the format percentage is basically saying, hey, if the column is a percentage column, make sure that you represent it as a percentage column. And don't worry, we don't need any decimal places, just whole values. So there we go. So you could see the tab spanner removed the little underscore from the header titles. And so now we're left with N and percentage, and we have a nice looking table. It's interesting, the table looks like that. When you pulled it up in the presentation, it had like a white and gray alternating, and the header was bolded. There must be some styling that Xaringan does when it sees a standard GT table, because you didn't style it that way.
Yeah, I think that's styling that's being done by Xaringan and GT when it goes to actually produce the
exactly.
The
it looks very nice.
Yeah.
Yeah, but yeah.
For sure.
There we go. Now we got a table.
Mm-hmm. One thing you may have noticed during that presentation is it first showed that table, and then when I clicked forward, it then showed looks like the big boss is correct tag. And the way you do that is you use this double dash. So triple dash indicates new slide, double dash indicates reveal more information.
Sure, like in PowerPoint when you do
Exactly.
the
Things fly in from left, right.
So what's
center.
what's the code in Xaringan for it to bounce in like you can do it in PowerPoint?
I don't know that off the top of my head, but I bet you somebody's made something that does that. I'd be
or like
willing to
spin
bet.
in like it. It spins in or something.
Exactly.
Like
So that's how you do the animation there. Next, we'll go into classifying. So, all right, new slide. Classify using the random forest. Here we read in that RDS file. If you want to learn more about how to produce the random forest fit, watch last week's episode 51. That's where we actually go more in depth. And then I believe it was episode 18, is where we go really in depth in discussing the random forest model and how that all works. Yep. So watch those 2 episodes. There'll be links in the comments below. So then we'll take that, we read in our fit data, then we do a predict using rffit on our penguins 2 data set to produce, then we're going to assign to penguins 2 species preds, because we don't want to overwrite species, because we want to actually keep what what was in the original data, and that way we can also do a comparison. So we're going to assign it to species preds.
And you're defaulting your predictions to the actual predicted outcome. If you look back in episode 51, we also predicted the probabilities, in which case it'll provide 3 columns. 3 columns that specify the probability of the data, of the observed data, falling into one of the 3 types of species of penguins. So in this case, you're just saying majority wins. If the highest probability was Gentoo, then say it's a Gentoo.
Mm-hmm. Exactly. More bullets about the model itself, because you typically want to give information around what you're doing to the people that are hearing your presentation. New slide, evaluation. Here now we're going to have some inline R code, very similar to Rmarkdown. So R, because I want to just produce this as state, because this presentation, you could present it. I could have presented it last month, and now we've got updated data running it this month. So here we're going to do a very similar, I guess this isn't super similar to what we did before. So we're going to use penguins 2, which is that data set that was the data set our text created. We're going to count on species and species preds so that we can get a count for the number of times we said it was one thing and the prediction said it was one thing. That way you can get that confusion matrix. So we'll just quickly run, here I'll just run everything ahead of us. So we're going to run this. So this is how we can get this count here of Adelie. So we called it an Adelie and the model called it an Adelie. And so we had 8 cases where that happened. Or we called it an Adelie, model called it a chin strap. There were 8 cases that were like that. What's going on there? We're going to use pivot wider to spin it out wide for us. And so the names are going to be from the species preds. That way the columns represent the predictions. And the values are going to be from N, which is the column here. So that way it populates it nicely in a wide format. I'm going to throw it into a GT. We're going to set the column label. This time I don't want to get rid of the species column because it actually does mean something. But I want to rename it to be original. That way it's representing the original species called. We're going to use tab spanner. And rather than doing the delimiter that we did earlier, I'm going to actually pass a specific label. I'm going to call that prediction. And it's going to be over the columns Adelie, Chinstrap, and Gentoo. And this is how we produced that confusion table in the presentation before. So we've got our prediction, original, Adelie, Chinstrap, Gentoo, predictions.
Why did in the columns label species HTML? Why did you need the break after original?
Because
what did it do?
I guess we ended up not needing that, so we can get rid of that. I was trying to get it to show up nicely here. I hadn't looked at it in the presentation. So in the presentation, because see how original is kind of in line with Adelie. I wanted it to show up in the middle because it's standing for this. It's representing this column.
So now that you changed it, it'll change it in the presentation. Or
I don't think so.
interesting.
I think that it'll center vertically
Oh, okay.
the spanner there. All right. So now that you've gone through and we've explained how to make this presentation, remember, our boss had asked us to run this presentation in a month and look to see whether things had improved now that we talked to our techs, talked to the database, and how to input stuff. Like, we're trying to reduce error in any way that we possibly could. So you now have this new data set that was provided to you. And so that is going to be called Penguins 3. Very imaginative name. But because you built all this with Xaringan, and you built it with Rmarkdown, it is wholly reproducible. And you just, in order to get that same exact presentation, but with the updated data, this is the only change you have to make. So now we click knit. It runs. And now we've got the presentation again that we can go through. So, title slide, episode 52, presenting penguins, TidyX screencast, the context, so what's going on here. Our boss walked in, they had a problem, complained too many penguins, arc being called Gentoo, it's too damn high. So, once again, looking at that reference set, it's still providing, it's the same presentation, but this time it's using the updated data. Our texts have gotten better. Our data collection process is getting better. The delis are now more at 40%, Chinstrap are more at 25%, and the Gentoo are more at 35% as well. So this now jives. This looks a lot more similar to the original Palmer Penguins data set. So it looks like things have improved for us. So it doesn't look like he's correct anymore, where there's not too many Gentoo. So once again, classify using a random forest. This is the evaluation as of today. There's still some misclassifications according to our model, but we can be more confident that our results are correct and that the model is now just incorrect. And there we go, and that's what we have.
And that's presentations in R.
And that is presentations in R using Xaringan and working on that. So hopefully that was helpful for you. I think Xaringan is an awesome package to help you create really creative, really powerful presentations. Lots of people are doing really fun work in extending Xaringan. Getting Buoy has several packages. I think it's like Xaringan Extra and whatnot, where you can do some like insane presentations.
And you did an entire conference presentation in Xaringan.
I did. Yes, I have. So so everybody should definitely start looking at Xaringan. If you went to RStudio in 2020 or saw this year's RStudio conference presentations, a lot of them were done in Xaringan as well. So there's a lot of flexibility around there. So you should definitely look into it if you haven't yet. Cool.
Awesome.
All right, with that, I think we can call it. So Thank you so much for joining us. Always appreciate it. If you like what we're doing, liking the video, put a comment down below. Click that subscribe button so we know that you're liking this. We love hearing from you all, so reach out to us. And as always, you can find me on Twitter at Allison_Hughes.
And you can find me on Twitter at OSPPatrick. You can reach out to us either commenting on the video or opening an issue on the GitHub page. You can instead email us at tidy.explained@gmail.com, or you can tweet us or retweet us or tweet us questions at tidy_explained.
All right. Thank you all so much, and keep on exploring your world.